Subject knowledge for teaching practice-based assignments. The class I'm choosing is a Year 8 Set 2 class. There are 32 number of students. The lesson objective, to discover pi by design activity. The lesson outcome, to understand the concept pi and the relationship between the diameter and the circumference. Introduction. Mathematics play a crucial role in shaping our cognitive abilities and understanding the world, teaching us logic thinking and mental sharpness. Despite its importance, many students find math challenging and uninteresting, often because they fail to see the real-world applications early on. Statistics from Ofqual 2023 reveal that nearly 40% of the students in England did not achieve a grade 4 or higher in their GCSE mathematics. In response, the government has made numeracy a core focus, ensuring all students in England receive mathematical education until age 18. To address these existing challenges, it's essential to ignite young people's enthusiasm for mathematics. As educators, we can employ strategies to foster passion for math and create an active learning environment. This presentation will explore effective practice from my teaching experience, which helps students develop an interest in and a better understanding of mathematical concepts. My sequence of lessons consisted 5 lessons. Lesson 1. Introduction to circles. Students should understand the basic circle terminology and parts of a circle. Lesson 2. To discover pi. Discover the relationship between the diameter and the circumference of the circle. In this presentation, I'll focus on explaining the application of this teaching activity in the lesson. Lesson 3. To find the circumference of the circle. Lesson 4. To find the area of the circle. Lesson 5, which is the last lesson, we are going to look at the real-world problem. Many people believe that success in math comes from rote memorization and firmly remembering formulae. Bowler 2015 suggests mathematics is a conceptual domain. It is not, as many people think, a list of facts and methods to be remembered. The tedious and monotonous rote memorization has caused students to lose interest in mathematics, which is one of the reasons for their poor performance in the subjects. My designed activity focuses on 2 aspects: increasing interest in learning math and strengthening conceptual understanding to avoid rote memorization. Skim 1987 suggests that rote learner has lower abilities and will not achieve the same goal in different environments and conditions. Brown 2023 states, rote learned methods can only be applied in the context which they were learned, and if the same principle appear in a different kind of problem, they will not be recognized. While rote memorization may facilitate solving particular problems that directly utilize those formulae, it hinders the capacity to appropriately adapt or apply the formula when confronted with unfamiliar or slightly modified scenarios. Bowler 2015 concluded, brain can only compress concepts. It cannot compress rules and methods. Therefore, students who avoid conceptual understanding and treat mathematics as a set of rules to memorize are missing out on a crucial process of compression. As a result, the brain cannot effectively organize and store ideas. Instead, they struggle to retain lengthy lists of methods and rules. This highlights the importance of consistently helping students approach mathematics from a conceptual perspective. Conceptual understanding is the foundation of mathematical mastery. It goes beyond rote memorization, requiring students to explore the why behind mathematical operations. Bowler 2016 finds the very best way to encourage the learning of facts and development of mathematical mindset is to offer conceptual mathematical activity that helps students to learn and understand numbers and number facts. And his research evidence shows students can learn mathematical facts much more powerfully with engaging activities. Minotti 2019 found students who have a conceptual understanding of the mathematics means the student has ability to represent, give solution to the problem, give judgment and explanation to the given problem. And in the process of the student should have the attitude, behavior, motivation, interest, and the taste to get achievement in mathematical learning. Well-planned hands-on activity focus pupils on the real-life situations, stimulates their curiosity, and guide them through the meaningful engaged experience in order to achieve expected learning outcomes. Eco study says students experience the fun and interesting learning process when they got chance to manipulate material to master certain content. As I mentioned on the previous slides, increasing interest in mathematics is a goal of my lesson. Horry 1994 suggests active learning brings many benefits for pupils, including increased learning motivation, enjoyment of learning, skill proficiency, communication skills, independent thinking and decision making, perceptions, and creativity. Active learning with various bases of learning activity are created with intention to encourage students active and participate in their own learning. Hands-on activities are part of the active learning and can be carried out effectively through group work. Hostman 2010 study found positive influence of hands-on activity experience on students' interest in respective activity. My designed activity will delve into the potent strategy aimed at enriching potential or conceptual understanding through hands-on activity. I found the Year 8 student greatly enjoy game-like activities. At the beginning of lesson, I planned an activity to assess students' prior knowledge of keywords related to circles. I have hidden the keywords under the random tables. At the start of lesson, students will search under their table to find the keywords. Once they got them, they will ask to come to the front to stick to the correct position. The prior knowledge check will help me to ensure all students understand the parts of the circle, allowing us to proceed with subsequent activity effectively. This activity is designed to spark curiosity and engage students' interest, setting a positive tone for the rest of the lesson. Scam 1987 suggests that to foster relational understanding of the formula for circumference of the circle, the idea of proportion should be introduced first. I learned this activity from SKE course. I find it very useful for discovering pi and understanding the relationship between the circumference and the diameter of the circle. This is a paper cutting activity that requires tape, scissors, a long ruler, and a color A4 paper. Students should work in pair in this activity. Step 1. Student will ask to cut 7 different lengths of the paper strips. The longest one should be 29.7 centimeter. The shortest one should be between 15 to 16 centimeters long. Step 2. Student will ask to take measurement of all paper strips and make sure they accurate to the nearest 0.1 centimeter. They need to turn the paper strip into a circle by joining the ends together using a tape. They have to make sure the end of the strip should be right against each other with no gap. Step 3. At this stage, students should realize the early measured lengths are the circumference of the circles. Now use ruler to measure the diameter of each formed circle. Make sure students should hold the paper circle as round as possible and take 2 to 3 readings to assure a maximized measured diameter. Step 4. Each group should have 7 different circles. The diameter for the largest circle should be between 9.4 cm to 9.5 cm. If the smallest circle formed by a 15 to 16 cm long strips, the diameter should be between 4.7 to 5.2 cm. Step 5. Students should record all the measurements into the table with 3 columns, which are circumference, diameter, and C divided by D. Once the table completes, students should find the mean average of 7 results and accurate answer to 2 decimal places. I demonstrate and explain the activity in front of the class, ensuring that each group had the correct equipment to proceed. To address my concern that students may forget the steps, I also display the instruction on the screen, allow them to check and follow the correct procedure. I walk around the classroom, monitoring the progress of the task to ensure I could provide immediate assistance if needed. As students experiment with different strip lengths and comparing the resulting circle, they begin to discover there is a consistent ratio between the circumference and diameter. The students began sharing ideas between groups, explain their found to each other. Even better, they help each other to complete the task correctly. After 25 minutes, I stop the activity and give students time to share their ideas. They began to find the concept that pi is the ratio between the circumference and the diameter of the circle. One group even shared the insight that to find the circumference of the circle, you need to multiply the diameter by pi. This collaborative discussion helped reinforce their understanding of the relationship between these measurements. Rather than passively memorizing formulas, students actively participate in creating circles and exploring their properties. This activity can be done collaboratively, allow students to discuss their observations and share insights and learn from each other. Boller 2009 outlets. Methods can seem to make sense when people hear them, but explaining them to someone else is the best way to know whether they are really understood. He also stated, verbalizing mathematical thoughts leads to a deeper understanding. For students, pi is a complex number. Through this activity, students can experience a fundamental simplicity of mathematics. They realize that mathematics can be so simple and feel the joy that mathematicians experience when they discover the new propositions. Exploring and discovering concepts can enhance the enjoyment of learning, increase students' curiosity about fundamental mathematical concepts, and consequently, boost their engagement and learning outcomes. Students' interests are not only manifest in the classroom, but also extend beyond it. In the picture above, one student, because of a slow pace, couldn't complete the active in class. However, she utilized her after-class time to continue the activity. She even emailed me to share her finds. It was a highly successful classroom activity, met my expected goals of enhancing conceptual understanding and fostering interest in learning. While the activity of finding pi by cutting paper strips is effective for many learners, it does come with potential drawbacks. This activity can be time-consuming, especially if students need to cut and manipulate numerous paper strips. It may not be practical for classrooms with limited time and resources. Based on this activity, I will refine the next one. To enhance efficiency, I will pre-cut the paper strips and preparing summarized sheets in advance, enabling students to allocate more time for reflection and research. Classroom management during the activity can indeed be very challenging. I find some students may become overexcited and distracted, leading to potential disruption. To address this, I will set clear rules and expectations for behavior during the hands-on activity. Reinforce the importance of staying focused and respectful towards peer. Use positive reinforcement to acknowledge and reward students who are demonstrating appropriate behavior and staying focused on the activity. This could include verbal praise, stickers, and other incentives. Students work at different pace. Some may finish early, while others need more time, making it challenging to keep the entire class synchronized. I would consider organize students into groups based on their progress, allow them to support and learn from each other. Establish clear checkpoints and milestones during the activity to ensure all students are on track and can receive timely feedback. Preparing additional tasks or extension activity for students who finish early to keep them engaged and challenged. SCAM 1987 found an instrumental teaching approach can make it easier for students to grasp material and accomplish by the completing tasks successfully. This approach simplifies the required knowledge, allows students to find the solutions more easily. I believe starting with foundation in conceptual understanding before progressing to procedure understanding increase the likelihood of students developing a solid understanding. In conclusion, prioritizing conceptual understanding in mathematics education is essential for nurturing proficient problem solvers and critical thinkers. In addition, to make math lesson interesting by using some hands-on activities, real-world examples, and technology to engage students. Differentiating instruction to meet diverse learning requirements. Engaging collaboration and connect math to students' interests can enhance their enjoyment and understanding. As a new teacher, I will continually learn and refine my method to make my lesson more effective and engaging.